Good afternoon, and thank you for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is electrical measurement safety. This topic is being presented by Sean Silvey from Fluke. Sean Silvey has been with Fluke Corporation as a product application specialist for the past 7 years. Prior to working at Fluke, Sean was in the HVAC industry for 15 years, working on residential and commercial applications. In addition to his wealth of technical experience, Sean has become an integral member of Fluke's Clean Energy Initiative, focusing on tools for the EV charging and solar segments. We expect today's presentation to last roughly 45 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Sean.
Thank you. Yeah, it's great to be here. Thanks everybody for attending this morning or this afternoon, depending on your location. We're going to go ahead and jump right into it. There's a lot of information to cover here on just some general information on electrical measurement and the safety aspects of that. So let's dive right in here. So, the industry estimates, so if you look at it, literally 5 to 10 arc flash incidents occur every day in the US. So this is a big topic. 77% of the recorded electrical injuries were due to an arc flash incident, some type of arc flash or arc blast that happened. And every year, more than 2,000 people are admitted to burn centers with severe arc flash burns. So, this is a big topic to try to avoid. And that's what we're going to look at today are some of the tools that'll help us do that. If you look at electrocution and shock hazards, this is a great slide that I like to show. There was a study done many years ago, and basically they did a study on what the feeling was when they gave a certain amount of current through the body. As you can see at 1 milliamp, there was a slight tingling sensation. Where we get into that 5 milliamp range, it was a shock was felt, but it wasn't painful. And it's ironic that typically our GFCIs in our bathrooms and in our kitchens are rated at that 5 and 6 milliamp mark. But as we jump up that scale, you can see that the shock becomes more painful. They begin to lose that muscular control. And even as we get higher and higher to where at just 2 amps, 2 milliamps, cardiac arrest could happen, internal organ damage, and even severe burns can be caused. So that's incredible when you think about in the US, typically our distribution panels and even our breakers at our residential are set for 10 amps. So we need to make sure that those GFCIs are working correctly just to help, mitigate that, and hopefully that shock hazard is stopped. But that's one of the key. I love this slide on that. So let's kind of go in and look at what is an arc flash. You've heard this statement before. It's created either by going to phase or a phase to ground short circuit. There's current that passes through the air. A lot of times that air then gets ionized. Air is a great conductor in that sense. Once that arc begins, though, it feeds on any of the matter or in anything around it, in which will start that vaporization. And literally this can happen within a second or even less. When once we have an arc flash, typically the arc blast comes next, depending on the energy that's involved in that. With that, you can literally have intensive heat. There could be a shock wave depending on how much energy is there and it's involved. Molten metal, shrapnel, that blinding light. If you go out and you look at arc blasts, videos on YouTube, it's a tremendous amount. It's incredible. A lot of the people that are involved, unfortunately, are fatally harmed, or there's severe damage to their bodies based on that arc blast. So what causes these incidents? You know, that could be racking in a circuit breaker, depending on that, the voltage and the equipment. You have to literally rack it in and spin it in to get it locked in. That could cause that. Sometimes there's loose panel wiring in the panel itself. Just going in, I've seen incidents where they're coming in and blowing out and cleaning out a connex room, something of that nature. Those loose panel wiring then instantly arc across and cause that fault. Even just removing a panel sometimes, you may have screws or fasteners fall in there, and by removing that panel as well, sometimes you disturb it and the air gets in there, and then again, move something around that causes that to happen. I've literally seen hand tools shorted across it. They put their tools up above, they're working in that cabinet, and the screwdriver or something falls, comes across the two phases, and that's where we can see that as well. Now, using incorrect test probes. Test probes are designed to be able, depending on your category environment and how much exposed metal is on the end of your test probe, as you saw in that previous picture, that arc blast or that arc fault was happening between those two exposed metals of that probe. So making sure you use the right probes for your category environment. And then maybe the measurement tool that you're using causes that arc blast and that arc fault in between it. Something in the meter created that short circuit. Maybe you were in the continuity mode when you were trying to make a voltage measurement. All of that plays into some of these incidences that could be caused that. So let's just quickly kind of look at the meter aspect of it. So, you know, when you're connecting your meter and you're going from voltage, you should be able to get that measurement. But if you're, you know, some of the older meters, if you were in the ohms or continuity position, they couldn't handle the voltage. They would actually create a short within the meter and cause that fault. So we want to make sure that you have the right meter when you're making these types of measurements. And if you have the meter accidentally in the wrong position, the meter can still safely get out of that, not causing that arc flash or all of that. So where did some of these guidelines fall in? I highly stress that you go out to the NFPA website. Part of NFPA 70E stresses safety in the workplace. This is the standard that's upgraded every 3 years. So every third year they revamp, add any additional information that needs to be part of that. And it really addresses your safety related workplace practices, maintenance of your equipment, any requirements for special equipment, and even that safety related on your installation requirements. I can't stress enough, this is a huge win for you and your organization to go out and look at this. It's free. You can go out and go out to their website and download the information or just look at it online and be able to see it. You know, when you look at that, it gives you information. It tells you what type of PPE you need to wear and what is that environment. You know, the PPE category ratings are necessary based on the potential energy that you're working on. Sometimes when you're working around a 120 volt residential outlet, something of that nature, you don't necessarily need to have that that 40 cal suit, but you do need to have the right equipment on, even if that's considered a category 1. It's based on the layers, it's based on that protection for you if potentially a fault should happen. So again, this is really key information. You know, part of NFPA says that all of the technicians should be trained. You need to be trained in your environment and trained with the equipment that you're working with, i.e. your meter. You need to know how to work your meter correctly and work in those environments. Part of your PPE, it actually states in the NFPA in 70E that your meter It's an extension of your personal protective equipment. So having the right meter in your hands and the right test leads in your hands is a huge one. So when we start talking about your PPE and those category ratings, depending on where you're working at, there are limits, these flash limits of approach. These are boundaries set up. The higher the energy, the larger the circle should be around your exposed environment. There's an arc flash boundary that basically anybody who wasn't trained to be in that area, this would be out on the farthest boundary possible. It's just allowing these people to walk past, but if something happened, you wouldn't allow them to get within that boundary. The next boundary is your limited approach space, and that's where we would want to make sure that people are trained, they're certified, they would have the correct PPE on to be able to get into that. They're getting into closer and closer to that arc flash environment. And finally, the critical one is going to be that exposed restricted space. And this is where all the work is really happening. You want to make sure that you have the correct PPE on, the correct equipment on, the correct meters to be working in this environment, because that's where the potential and worst of the arc blasts could happen, would be in that restricted space. All of this information is part of the NFPA 70E. I again highly recommend that you go out and look at it and start learning how to do those load studies on your approach boundaries, your limited approach boundary, and your restricted area spaces. As I mentioned, the test instruments are part of your PPE. They need to be rated for the circuits and the equipment that you're going to be connected to. They need to be designed for those environments which may be exposed in this manner, and where you're going to be used. You need to inspect your equipment daily, if not weekly, but daily. Make sure that you don't have a defective or damaged equipment or test leads. Again, these are the tools that, you're out there doing these jobs. You need to meter to make those measurements, whether it's voltage or current. They need to be in good working order. You don't want to be part of those statistics, just like on slide one, that arc flash or arc situation happened. So we just want to make sure that our tools are insulated, we're working with the right meter, and that it was tested, and that we verified that it's tested. How we can do this is actually going through a live dead live test. This is also part of NFPA 70E. We want to go out and do a live dead live test on our meter. This is where we turn the meter on, we do a voltage measurement, we actually turn that source voltage off, we do another test, we validate that the meter is reading 0, and then we turn that source voltage back on and validate that it's reading the voltage, whatever that may be. That's a good live dead live test. We've verified that the meter's working correctly, it's functioning correctly, and we know that you're going to be safe when you go out there. Now, a lot of people are going out to job sites where they don't have a known voltage source. Maybe there's a voltage drop, something of that nature. They don't necessarily even know what the voltage may be. So how do you know it's a known, a voltage that you can do? So what we also have is like a proving unit. Get out there, use a proving unit. This is going to allow you to quickly and easily at your truck or wherever that may be, even on the site, to properly do a live dead live test on your meter and validate that it's working correctly. Again, this is a great little tool. It uses batteries, simulates 240 volts for this one, and then that way we can prove out that the meter was working correctly. Again, we can do this also with AC or DC and give you that 240 volt. It's part of the 70E. As you can read down here at the bottom, it's part of the 110.4 standard in that, of just making sure that your instrument's tested for that absence of voltage and that we want, that it's working correctly. And that's really the key win. You know, the whole part of this conversation is really safety first. When you're working on energized lines, or if they're not energized, follow those lockout tagout procedures. If you don't have that in your facility, you need to do that, because again, if something's not locked out correctly, they think it's de-energized. Somebody comes around and works on it. Now we again have created a fault. We've created a statistic that a blast happened, a fault happened. We want to, mediate that. Also, make sure that you're using the correct PPE. You're using the right PPE for the right environments. Make sure your safety glasses are up. You're using your insulated tools, insulated gloves, any of that arc flash rating that we talked about, about your category rating of your gear. All of that helps. Don't work alone if you can help it. It's very difficult. I know when I was in the HVAC industry, a lot of times we were solo out there. We were doing a lot of service work, but at least checking in with the front desk, checking in with everybody to tell them where you're at and what you're going to be working on. That's a key win on that. And just practice those safety measurements. You know, this is a great technique when you're doing voltage measurements. You always want to connect your common or your black one to a ground, and then you will check with your hot, do your measurement, pull off your hot, and then pull off your ground. It's just a great safety measurement. Depending on what type of meter you're working with, you may have voltage running through. I actually heard a story of a guy who had put his red test lead on voltage first. He went and was about ready to put his black one on. He got an itch on his nose. He went to rub it with the black test lead in his hand, and it seared his cheek because the meter that he was working with didn't have enough internal impedance, and it basically gave him a scar for life. So good practice is always going black on, then red on, red off, black off. And always use that live, dead, live test. Make sure that that meter's working correctly. So you also want to make sure that the meter is part of the IEC 61010 guideline for the standard for equipment on these low voltage, meters. Now, when I say low voltage, that's 1,000 volts and less. But make sure that your tool is rated correctly. Part of that is your category ratings. We want to make sure that the meter can actually handle the category environment at that 1,000 volts, or maybe it's 480 volt 3-phase that you're working with, because voltage out there can have problems. If you think about it, a lot of transients are out on these lines. These transients are what's causing some of the issues with our equipment, whether it's inductive load switching off, maybe there's an equipment malfunction, maybe there's even on the utility load side that they're doing some switching. Adjustable speed drives can cause these transients. All of those have potential issues that could cause a fault or cause a blast, even a lightning strike. And that's a very obvious one. If you think about a lightning strike, that's causing that incredible amount of energy going into it. These transients are invisible and they're very fast. Sometimes they happen in under 100 milliseconds, so they can be incredibly dangerous. And if you're connected to some type of equipment or something making that measurement, that transient can now has the ability to go through your meter. So that's why category ratings on your meters are important. Knowing the category rating and knowing the environment that you're working in. This is a great slide because I like to go into this and kind of give an education piece about your category environment. This is different than the PPE category ratings. Now we're talking, that's part of your PPE category. This is part of your electrical environment. If you look at category 4 environments, these are part of the utility. These are basically out on the lines, out into the transformers of the utility. These are typically your 3-phase connections on that side. Once we get into that 3-phase, that Cat 3, It's a three-phase distribution, but it's typically internal to the building. That's where your category 3 environment could be. And as you can see, that voltage can be 480, 208, just depends on what you're working with. And then that category 2 environment is those single phase receptacles that I was talking about, kind of those residential, those 120 volt, depending on what you're working on, even sometimes a 240 volt for air conditioners. I've seen plug-in air conditioners have a 240 volt. That's still considered a Cat 2 environment. Now, a lot of you are working in the solar industry and working in renewables. And I like to highlight that in the category 3 environment, that's where your solar arrays are. That's all fixed devices. The category rating part of the standard now is it's a category 3. Going into the inverter, still a category 3, but once we get inside that inverter, we're now back to a category 4 environment. Again, back to the utility side of that. And then going back from the utility back to whatever that energy is being consumed. Great slide. Know your category ratings because it helps you with your equipment on the right equipment that you need to choose for that environments. So really, when you're working with, 1,000 volt, 600 volt, or even 300 volt, we need to know what that is. Most DMMs and clamp meters are dual rated. They will meet a different category environment. So typically, you'll see on a meter, you'll see a category 3 1000 volt, but it's category 4 600 volt. Or I've seen in some meters a category 3 600, which puts that category 4 at 300. That category 3 1000 volt, that can withstand that 8000 volt transient that we were talking about earlier, where a category 3 600 volt can only withstand a 6000. So it's really important, and it is the bottom line and most important, to just know the measurement category and the voltages you're working in. Having that right tool for the right job is going to be a key win and to keep you safe out in that field. Again, remember, your meter is an extension of your PPE. So we want to make sure you have the right tool. Now, where can you find this? This is typically near the input jacks of your meter. As you can see on this slide on the left, you can see the category 3 1000 volt, category 4 600. On the other 2 meters in our clamp meter, you can see it also at the input jacks on the meters. Now on our clamp meter, this one here is designed for category 3 1500 volt. So just know those markings, know where they're at, because that's really the key win with that IEC 61010 standard. And when you get your meter, understand how to use it and some of the warning limitations of it. With your meter, you're going to be able to read and understand those warning signs. I'm just as bad as everybody else when it comes to getting documentation and throwing it away. So, it's really kind of critical to read it before you use it. Now this side's great because, a lot of the older meters, and I go to trade shows, I hear stories that, hey, I'm using the original meter my dad used. My grandfather gave me this meter and it's been great and it still works great. But just know that these meters are unrated, underrated, or they're insufficient. That older meter back in 1983, that Fluke 70 series. I know people still have this Fluke meter. It's actually not rated for those larger category environments. It wasn't there at that time. Even the original 1988 Fluke 87 series, still an amazing meter. It doesn't have the right rating for it. I highly recommend if you have these meters prior to like 1997, they no longer meet that code. You need to get them replaced for the new environment that we're in. You can still use these meters, but use them in those category 2 environments. I highly recommend that. But once you get into the other ones, you want to get a different meter. Also, too, make sure that the products that you're using have been tested. and certified. That's another safety win in this conversation. Make sure that it has that CSA or UL listing on it. These are key because they've gone through a third-party independent certification. They've been tested. They validate, that manufacturer validates that that meter's qualified and meets that IEC 61010 standard. So that's a big win as well. Because these meters are really truly designed to protect you. Again, this is part of your PPE. Fluke literally devotes 10 to 15% of all the components in its meters exclusively just for protection. That's huge. The category rating stand, we can run our meter through and do testing. There's videos on YouTube where we've taken our meter and tested it at 8,000 volts and ran a transient through it through our lab, and it handled it versus other products that are not designed for it. They say they designed to it, but they didn't. So it's a key win again to make sure you have the right meter for the right job. When you put a Fluke meter and you may be accidentally running on voltage and put it into that continuity or resistance mode, there's enough internal protection that's going to protect you that it's going to give you a warning, but it's not going to blow up. It's not going to cause an arc flash or an arc fault in that. That's a huge win. On some meters too, if you have your test leads in the wrong position, there will be a lead detect on it. The meter is smart enough to tell you, hey, you've got the meter test leads in amps and you have the position in volts. You need to run and change that. If you think about the meter, when you put your test leads in common and volts, it's like using a rubber band. It's a lot of resistance there and a lot of protection. But when you put your meter in common and amps, it's like a paper clip. It's solid metal, no resistance. That's where a fault could happen. So again, have the right meter for the right job. As it's mentioned here with fuses, make sure you put the right fuse in the meter as well. Use the fuse that's rated for this meter. How many times have you gone out, and we're not talking meters in this case, we're talking about just applications. I've literally gone out and somebody put a nail or something where a fuse should be in a split phase panel. Inappropriate, unsafe, could potentially cause a serious fault because they didn't take the time to go put the right fuse in or do the job correctly. Fuses are there for a reason. If you have a potential amount of current, voltage, or current running through it, it's gonna fault, it's gonna crack. That's what it's designed for. So make sure that you use the right fuses for the right, for your meter. So let's kind of move over now and start talking about some other products. Let's talk about your test leads, because again, this is an extension of your PPE. Make sure that your test leads are rated appropriately. Do a physical check on them. Make sure they're not wearing down, because if you're touching 480 volt and you have a nick in your test lead, that could potentially touch you to cause a fault or some type of incident. So just double check, make sure that you have the right test leads for the right job. They should be rated. You should be able to see the category rating on your test leads. If your probes are broke, if you got fraying on it, the insulation's pulling away, replace them. It's a inexpensive, if you think about it, even if the test leads were $50 a piece, that's still inexpensive compared to a hospital bill or a major incident that happened based on your test leads. So make sure you use the right test leads in your category environment. Ohm them out, like in this bottom right picture. Make sure they're not breaking. You can easily do that with your meter and do that. Now, I mentioned about the exposed metal, and this is critical. Some of our test leads will either come with caps or we can twist them. The exposed metal changes the category rating of your environment. The longer the metal, the lower the category rating. As you can see here, that 19 millimeter goes to that category 2 environment where the smallest amount of metal exposed, we can keep that category 4. So it's really critical. Don't throw those caps away. If you're working in higher category environments, we want to make sure that the less exposed metal is critical. You can even see the designs in the IEC changes. No longer do we have exposed ends that even go into the inputs of our meter. They're now shrouded. It's all about safety, and it's all about that safety out there in the field. What if your test lead came out as you were touching metal? You touch that, now you're shocked. So again, a key win, all part of that standard, that IEC 61010 standard. Voltage detectors, they work amazing if you know how to use them correctly. They use what's called a capacitive effect to ground. They use your body actually as a ground reference. And that's the key win on this. So knowing how to use these. For years and years, people would come to me, tell me that these are widow makers, they don't work right. And I had to explain to them how to properly use them. They're great. They can easily check if you have voltage on a circuit, if you have voltage present on a line. Again, another safety play to make sure that if you're working in an environment, you think the voltage is off, even using something like this would help determine if voltage is there or not. This is not a live dead live though. Always go back to your meter when making these types of measurements and confirming that. Now also too, another win is FieldSense. This is a new technology that allows you to safely work without using your test leads. The picture here shows that the conductor, there's a sensor where this little V is, that's called FieldSense. And all we have to do is touch the wire in that sensor area, it will give you the voltage and current. We no longer have to use our test leads to try to get into a junction box, get behind wire nuts, something of that nature, which could, again, potentially cause a fault. So look at this new technology, because this is a win as well for making non-contact voltage and current measurements. Now, when we think about separating ourselves from that boundary, we still need to make measurements. Using some type of wireless tool or a Bluetooth incapable tool is a huge win. We can set up the meter, we can link it into our smart device, we can pull ourselves away from that restricted boundary area and make those measurements. We can pull off a little bit of that gear during that process. Really, that's a key win. Again, this whole conversation is how to safely work in those environments. We identified the flashes, what could happen, but making sure that we can stay away from that boundary is going to be where the safety is. Also too, even now we have remote configurated type of tools where you can remote configure like an insulation tester, getting in, configuring, doing high voltage insulation tests, but staying out of that boundary. So really that's the key win when we talk about a Bluetooth or a Wi-Fi device, keeping you out of that zone. These devices, you can literally view up to 10 different measurements at one time. So if you're making voltage, current, whatever that may look like, three-phase voltage, three-phase current, you can easily hook these systems up and look at it from a distance. Really a win on that. Now, another tool that's really critical and keeps you safely out of that zone is an infrared camera. These items are heating up. With the heat causes a fault. Going in and maintaining and being able to pre-check with a thermal imager is huge. We can safely do this from a distance. Again, it's increasing that safety. We can look at live voltage and live situations on panels, on motors, and again, document and see what's happening. Because the more we document it, the more we see it, the potential of catching that before it faults is going to be critical. So again, another safety play on that. As you can see here, some great examples of situations that we can see excessive heat. We're troubleshooting problems on an electrical side. Maybe we're checking there's an unbalance on a three-phase system. We can easily see where that's happening. You can see loads on a panel on this one and the third one from the left, that's causing a problem. Even the heat on your transformers and seeing where those potentially could fail. A key win on this, and again, keeping you safely out of that situation. Now, we talked about opening up those panels and seeing that load. You can put in an IR window. It's a device that's specifically designed for thermal imagers. A thermal imager will not look through glass or anything of that nature. It'll reflect back. If anybody's seen the Matrix movies, you can look at the lens of one of the agents, and literally that's exactly what it looks like. You just can't see through that glass. So these IR windows do allow you to do that. And how safely? The cabinet's closed. You don't have to put your PPE on. All we have to do is roll back the door for it and do a visual scan and see. Another key win. It's keeping you safely out of a potential arc flash blast or an arc fault. So really, and I said this enough at the beginning, your employees shall be trained. Make sure that the employee is trained to work in that environment, that they select the appropriate test instruments, the gear that they need to use. They know how, they can demonstrate how to use these types of instruments. They can interpret the results. That's another key win on this. And understanding the ratings of those test equipment. You got to know the category environment that you're working in to be able to know which equipment you need to work with, that you're going to do your visual inspections on the equipment and your accessories. You're going to perform those operational verification tests like that live dead live test. And even being trained, you can even, identify if there's a misapplication of equipment or of something going on. So make sure that your employees are trained and know what they're doing. So really, bottom line, keep safety at the top of your mind at all times. Fluke has done multiple studies on safety in the workplace. One of the first questions that comes up is who's responsible for safety? Literally 75 to 80% have all said me, you. You're the one who has to be the one to keep safety at the high level. By you doing it, others will follow you. So stay up to date on your safety standards, know your codes, go out and download that NFPA 70E, know some of the standards and the information. It's really incredible information for you. Select the right tools that you have for the job. Remember those category ratings I talked about, those voltage ratings on your tools, and audit your equipment. Make sure that you have the right meters for the right job. Don't be using those older meters in the wrong category environment. Verify that they're ready to go every day. And if you need to, order spare parts, order those spare fuses, have extra test leads on hand if you potentially get an arc fault. I've worked with, when I was out in the HVAC field, I went up and measured, literally had a nick on my test lead, had a nick, just happened in a second. You need to replace them. It's keeping you safe. And really make training and briefings part of your daily work life. It's important that the whole team stays up to date. Electrical safety, environmental safety, all of those need to be discussed on a weekly or 2-week basis about what your team is seeing out in the field and how everybody can work together and work safely together to bring you home safe at night. So that's a key win. So at this point here, we can go into any questions we might have.
All right, thanks, Sean. That concludes our presentation portion of the webinar. We'll now move into the question and answer session. Just as a reminder, if you would like to ask a question, please send it through the question box in your webinar controls. All right, let's move on to the first one. How often do arc flashes occur in the US?
You know, as I mentioned earlier, they're literally 3 to 4 per day. I mean, it's incredible the arc, yeah, when it happens. And we don't identify it. A lot of them go on what I want to say. They're not documented down that this happened. Maybe it was something out in the field, but there's a tremendous amount that happen every day.
Okay. And the next one, how does NCV ground to the operator?
So, so non-contact voltage,
Okay.
it basically uses you as a capacitive, it's called a capacitive coupling effect, and uses you as a ground reference. Now that basically uses your internal resistance of your body and a ground. Your feet are basically touching the ground. That's how that works. Now it doesn't work well if you're on a rubber mat or you're on a ladder or you're on something that you're not grounded. So that's where that key win is. If you're using like a non-contact voltage alert and you're on a ladder, you want to touch something that's grounded, metal piping, something of that nature if you're using that type of device. Now with the T6 and the 377 and 378, they actually use the common test lead. They want you to ground it out separately to get that ground reference for you to make that measurement.
Okay, and the next one, do Fluke multimeters default read in RMS?
Yes, so most Fluke meters, and you will see that it will say true RMS, they will default as soon as you turn them on. That will be a true RS. Now, there is an average responding aspect to most of our meters. There's a little bar scale in the LCD screen that you can look at. 90% of Fluke's DMMs and clamp meters will be true RMS meters. There are a select couple that are they're average responding, but not too many people use those anymore out in the environment. Only really our military has still used the average responding type of meter. Good question.
All right, looks like we have another one. If you are wearing EH rated boots, does that impact the function of a non-contact voltage detector?
Yes, it does, because you've got enough insulation and resistance in your boots that you're not going to be a good ground reference.
All right.
Yeah, same with gloves. I mean, all of that plays into that value. So especially with the T6 and the 377, like I said, we specifically give you a common ground wire to ground out.
All right, that looks like all of the questions. So that is going to conclude our time for today. If you have any further questions or would like to find out more about Transcat's product and offerings, please contact us at 800-828-1470 or on our website at transcat.com. Thank you for joining us today. We hope you got something out of today's presentation and that you continue to join us for future Transcat e-learning webinars. Thank you, Sean, and everyone have a great day.
Yeah, thanks everyone. Be safe out there.
All righty, thanks. Bye-bye.